Hooray. All right. So yeah. Um, so I started this task that I had here to merge the links pull request, and the stream wasn't actually working. The OBS was working, and I didn't notice that it wasn't actually streaming on Twitch, so you missed it all. But it doesn't matter because I didn't actually manage to do anything. Because when I tried to pull the Linux version, it kind of seems like it worked fine, but it gave me this first line at the beginning, so I don't trust anything. It's a version control system. If it gives me an error message while it's doing stuff, I don't trust anything, so I backed out of it. And I Googled this error message and didn't get anything useful. So I also posted on Twitch that same error message to see if anyone has any info. So I'm not going to merge that pull request because I don't know what's going on there and I don't want to take any chances. I mean, most likely I could do a diff and discover if I missed anything or whatever, but insofar as if you have a Windows machine as well and you want to try merging it yourself and see if you can figure out what's going on there, I don't know. It's weird. All right. Anyway, so I was going to do that because that was on this list. I hadn't mentioned it before. And I did also want to just so people know, since I mentioned I turned on the air conditioning, this is why I turned on the air conditioning. Because it's nice out. And let me just see if I got any replies to the tweet. Like I said, it's probably okay. Like, why is Git trying to run sed? Like, the whole thing of dependencies on other programs is frightening. Like, so let me just see if anybody replied. No. Okay. All right. So we're putting that on the back burner. Well, permission denied. There is no bin sed at all. That's just the wrong error message. There's no bin sed. There's no file there. Well, maybe there is, but I don't think I have a bin directory. That won't work in the shell. Yeah. It's just what they printed. So yeah, I don't know why they think they're trying to run sed. Like, don't know what path that's taking. Git sh setup, setting up the shell. Or it's a shell script that does setup. Who knows? So anyway, so we're on to this. So what I said at the start of this is that I was going to write the so what you missed, what you missed because I ran the stream and the stream wasn't working because I was just doing cleanup, so I wasn't really worrying about it and paying much attention, is I put this the memory dump here onto a switch so you can turn it on and off. Let's bring it up again. I was wondering why chat was being so silent. So now I've turned it off. So it's on the toggle now, and it doesn't default on. So the other thing I want to point out here is this code still needs more work. There's this whole thing where like things start with /logi or /worker, and the idea is that you can merge the things. They form a tree, like a file system tree, but you can then look at early nodes in that tree, like /worker, and say what's the total for /worker, and what's the total for /mapgen, and what's the total for /logi, and that would be useful in the long run. But right now there's so few allocations, and they have such a dramatic drop off in their curve that the only things that matter are the top few, and I don't really need that info yet. So I'm not going to do the work to make a sort of navigable tree that you can drill down into. But that's what that's there for. That's why you have names like logi chunk, because there might be other things that go in the logi chunk, and besides the chunk itself. Although it looks like I put everything else top level, but maybe they should have been in the chunk. Anyway, so that's that. Now it's back to the good state and all that. So when I started, I said I was going to do the memory monitor and the performance monitor. And I'm happy to do that. But I was thinking that maybe spending an entire 8 hours on memory monitoring and performance monitoring is perhaps not very fun, not that interesting. Maybe I should come back to the performance monitor another time. It's, an open question. Why is it taking so long to build stuff? I mean, I still haven't actually run in release. I guess I could do that. And it's still something I need to explore, but it's not necessarily the highest priority thing to explore. It was just a thing like, I got to get to that someday, so maybe I should get to that. And the memory was important because I was having crashes due to the out of memory. So now maybe I should put off the performance profiling and go back to the last thing I was working on, which was game system-y stuff, which I guess was I believe it was trying to sort of get the crafting tree to start having, you combine these things to make one of these things, and then combine those things to make another thing, and start turning it into an actual gamey kind of system. But I don't have strong opinions, so I just figured I'd see what people watching feel like. I don't think either of them are going to be more interesting to watch. Like, the game stuff maybe sounds more interesting, but it'll take a while to get there. I have placeholder art, and I have to make more placeholder art, and so it's not going to be all that exciting to get to that point. Then I'll have to start worrying about having some kind of inventory scheme. But I could do that instead of performance monitoring. Oh, it has to have ore under it. I forgot about that. Don't know which one's ore. Is there an ore on this? Yep. Or I could go and start looking at these bugs. The Logi belt bug here. Is that a chunk boundary? Where are the chunk boundaries? I can't see them. There's the chunk boundary. Nope, that's not at a chunk boundary. It's just a curve boundary. That's a bug. And the thing I just changed is supposed to get get these going by. And there's also this bug when it comes down the ramp here, where it will goof out for a moment. Yep, so they both have that bug. Yeah, the minimum effort, maximum impact is, of course, always the way to go, but then you're just sorting everything by that order, and it's kind of... Where's the curve? Do I not have the curve on a... I guess I don't have the curved one. Oh, there it is. Oh, it's the wrong curve. Do I have a way to flip that? Nope. I don't think I do. Oh, conveyor right. I don't have a way to add conveyor lefts. Oh, that is the right way. Okay. All right. Well, rebuilding it somehow fixed it. I don't know what was going on there. A bug in the logi system, I guess. And it's Factorio style. They don't fall off the end. They just wait. Things that are on the to-do that you never get around to because important things are more. The things at the bottom of the to-do are rarely minimum effort, maximum impact. They may be minimum effort some of the time, but I don't know that my to-do list is sorted by priority anyway. It's not. Factorio-esque. Did enough of that. Changes to disks, conveyor belts, or just one row of block size stuff. Yeah, I think instead of that, so what I was thinking is instead of the double rows for the ore, just having a single row for the big block shaped thing, you know, like you have to build the machines and then pass the machines around. But I think I'm going to just stick with the Minecraft, and I think Factorio does it too, kind of convention that no, when they're on the belts, they're just small. You know, it's when you drop inventory in Minecraft, the objects are all tiny. Blocks are smaller than full size. Everyone's used to that at this point, so so I think rather than deal with that complexity, it's easier to just roll with the easy thing. We already kind of have that. Mine ore from ore blocks, we have the beginnings of that. We don't actually deplete the ore. Yeah, so those are various things we need. Yeah. Possible tasks to work on next. Here we go. Promises on conveyor belts. That's just a way of cleaning up some of the conveyor belt logic that we have currently. They will allow more flexible pickers who can pick from multiple places on a conveyor belt instead of currently they just pick from one spot right when it rolls by that one spot. But because we have these flexible arms that can reach arbitrarily, they could be picking up from other spots, and that's what you see those real arms are for typically, is they do allow this flexibility of where they pick up from. So it would be nice to do that. And so we have to augment the conveyor belt to, in each ore slot, you need to be able to tag this is somebody else is planning on taking it, so nobody else take it. And likewise, somebody else is planning on putting something here, so nobody put something here. So that's a thing we could add. Real driller machines attached to specific block types that have ore. That's the thing that we started doing. Furnaces, assemblers. Liquids is a further down the road thing because we have to start having to think about liquid flow and stuff that I don't want to deal with really. We could add power. It's also in Infinite Factory. Kind of. Oh, I see. I reposted down here. So I should remove those from down here. Enemies and tower defense. Assemblers and furnaces. Liquid is down there. Power is down there. All right. Nobody has super strong opinions, so we're going to do perf work. We're going to do the performance monitor. So, what do we want to do? well, we're threaded, and I don't want to write a whole whatchamacallit, telemetry. Telemetry is a rad product that has a timeline view. I don't want to write a telemetry style thing, but I do need to get some info from the threads. So I think we're using SDL. Functions for this, yeah. Get performance counter, get performance frequency. So we have this bad profiler that doesn't do the right thing or something. When it runs a job, okay, if there's no next task and the stop worker flag is set, right, okay, that all makes sense. So we're never profiling the get next task, which actually does a bunch of work, but that's okay. All right, so this all seems reasonable. We just measure the performance. If we get swapped out, it's bogus, but we can't do much about that. And then what do we do with it? All right, so we need a mutex for this. Well, we don't. Well, we do, because the other thread, the main thread, is going to look at it some of the time. Now the question is, how many places do we call this at this point? Yeah, that's the only place. How long have I been scripting C++? I've been programming C++ since I mean, I'm 1990-ish, but I barely ever use C++. I just use C, but still basically the same time frame. I probably learned C in '88 or something like that. And we need to initialize that. Oh, right. Yeah. Let's do it the same way. Data, bro. All right. So maybe that will add something useful. And then thread timing data. Do we do anything with it? No, we do not. So query thread info int ID int count double time. So time spent. Let's go to the time count. And we reset them. All right. That will give us some kind of thread data. Now, if we want, we could actually flag which job it was and get more data from that, and we can go down that road later. So now let's add that function. Query thread info. And let's just go ahead and start with that. So, where's our debug output? Oh, I'm in Mesh Builder, not main. Debug output draw stats. So, struct. Should have actually typed up it. Struct thread timing. That's going to have int count, and then it's going to have a float count actually, and a double time, and then we're going to say void update thread times. Threads. That's probably already a variable, actually. Max mesh workers. Put that in the header. Oops. And then back in main, max mesh workers. Go. And then let's check ID. Red ID. Red ID. These are indexed starting at 0, right? Which is that? What that does? Okay, good. Query thread info, I, comma, count. Time. Okay, the question is, do I want to show these per frame averages, or do I want to just show per second averages? Or like, because if I'm just going to update these every second, let's say, how do I find out what the time is per time? If initialize update, last update, time equals per time over frequency. if per time per double SEL, we get performance frequency is greater than or equal to. So what units are these in? Frame time. Frame time times 1,000. To get it to milliseconds, so it's in seconds. Okay. It's greater than or equal to last update time plus 1. Then last update time equals current time over double STL. Get performance frequency. Yeah, there's the stb.h has had 64-bit updates, but maybe that one hasn't. Maybe I rolled it back or whatever. The other thing is that the entire system that's making that assert should just be deleted from stb.h entirely anyway. So I'm not saying you should do it. I'm just saying, like, that's the status of that system. All right, so if a second has passed, we do an update, and then we call update thread times. So do I want to divide this by the number of frames or not? I think what we'll do is we'll say thread timing I equals. I think we won't. I think we'll just. I think for now we'll just leave it as is. Bingo. Is it max mesh workers, not no mesh workers? Yeah. No parentheses. This is the old code. Did I change anything about this? Oh, I got rid of the second bracket. Never got rid of this. Yeah, I'll keep them red just in case I decide I want to do the same thing. Yeah, the fact I couldn't find any info on the said thing. That's the problem. I googled for it and I saw one person with the same problem and not a useful reply. And okay, I forgot to divide by 1,000, so they're taking slightly more than a second in the last second, but that's fine. That's because like the discrete, it's only measuring them at the ends of the job. So, okay. So maybe it's worth distinguishing the kinds of jobs. So let's go without bothering to fix this separately. Let's go ahead and update that. So query thread info. It's job. Make that be an array. All right. And then that doesn't change the public API, so add time. Job. And that was T task type. So we can just T task type equal job build mesh. And we'll just clean that up later. And then where do we query this? Here. And this could be a mem copy or something. But if we ever go to more than 2, then we will do that. %g jobs build %3g mesh count 0 red time 5 count 1. Oh wait, what was the thing that was wrong that I wanted to fix? That I said I'd fix at the same time? I forget. Oops. EO6. Okay, so there's a lot fewer builds and a lot more mesh gen, it looks like. Which means that's because the gen chunk cache is working. I guess that's correct. Hooray. Or there's a bug. Why was that exceeding? Did I not zero that one correctly? Zero, zero. I didn't fill it up. Oh, no, it's the opposite. Ton of builds, very few meshes. So the cache is not working very well. Each mesh needs 16 builds, though, so it's working some. But we can expect that where the time is going is probably in the builds. I'm not actually breaking down their times, though, so you can't tell for sure. Maybe I should break those down. What am I looking for here? Oh, I'm in the wrong file. Dot time, what's it called? Time. 1. So much copying, I could be passing them into each other. If I just made these types public, I just want these to be out of sync from each other though. So that they don't have to be strictly coupled, even though they currently are. Now they probably won't line up, so I'll need to use the print column stuff. Close enough. So yep, spending most of the time building and a little of the time meshing. And then I can also profile the main thread, the render thread. But if you look at CPU frame render time, it's so small, there's probably no point. Don't really care about the details of where that time is going because that's not what's blocking us. But maybe we need to start breaking down some subtimes within the build. I could just run very sleepy and see what it shows. But I think I want hierarchical, better hierarchical info. So I need to start figuring out how I would visualize if I start giving them sub-regions of build and a more systematic way to pass that info across now. So let's start by splitting this. It's a little wrong because it's missing the. So there we go. That. So code's exactly the same as it was. I just moved it inside the switch so that I can start modifying them. And now this, I know whether it's build mesh or not. This one is build mesh, and this one is generate terrain. Okay, why did I do that? Because I can now split this. Let's change this to simplify things a little bit. We're going to make add time automatically call end. What type is that? Where do I declare these? uint64. Start. This is end minus start. Okay. Add time. Sure, that seems reasonable. Now it should get less tasks done because I'm in a debug build, so it should be getting less done per frame, per second, I mean. And now we can get rid of the end call for that one. So now if we want to separately do this, we can do this. First we do the generate chunk, and then we separately do everything else. And we need to give these different IDs. So let's change our whole system. 0 is going to be gen mesh, and 1 and higher is going to be this thing. And just have a whole bunch. Not worry about the exact number. And then this, we're going to memcopy. Executed. Should we just use size of ID times executed? Then we have time spent. Time spent. All right. All that, then we have to mems it. All right, seems reasonable. 32. Where's that? Does sprintf return how many characters it added, I think? I don't remember if it includes the 0 or the null at the end or not. Oh, would have been faster to... Not counting terminating null, okay. What was it copying to at the end there? Put chunk in cache. That's the main thing it does, is put chunk in cache. Okay, maybe. Soon, in a moment, you will see the method in this madness. There is a thing I'm planning to do. I just want this easier change to work. If this easier change works, then we can get going. So are the first 3 going to get populated, or did I have a bug? Break. Which thread? Which thread has gone mad? Copy up. What the hell is that? Mem copy. I didn't fix that. Yep, I didn't fix that. Okay. Yep, and we're getting garbage. We get some nulls. So something's not initialized properly. And hey, look, right here. J. Or J equals. Didn't finish doing everything I need to do. No, wait, these should still be 2. No, wait, these should be 32. Yeah. Alright. Come on, work this time, please. Please work this time. Please work this time. Okay. Gen cache. It's taking all the time. No, it's the one on the... Let's reverse the order so that I don't get that confused. Task. Where do we put task? Task. Colon. Now task is at the left. Alright, I'm going to assume that worked. So now we can move forward. So what other tasks do we want? So here's the whole point of this. This thing right now, right here, brackets it. So we can move it down inside generate chunk. Dun, 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 dun. Int 64 start. And let's make sure this malloc falls inside the profile region. Okay, so this is where we end. So for now, if we put the end all the way at the end, bark, that should not change anything. Except currently we can't call it because it's too far down. So we need to go move all this stuff up. And this is definitely dead at this point. This moves up to the top of the file, you know, here. Alright, so at this point, I haven't changed anything. It's still bracketing the whole thing. But now we can start doing it in steps. Well, let's go ahead and run it once just to make sure I didn't break anything. Does this thread know this thread ID? No, it doesn't. So we gotta pass it in. I think this is the single threaded version. And this is the thread ID. That needs to go here. And correct. All the time is being spent in gen. Okay. So now we can start splitting that up. Find the end. Okay. So what do we have to do? First, we have to go there. Copy this. So 2 is height field. 3 is populate. 4 is or. Which is just a hack. Kind of just a hack. We need to figure out the real way to do the logistics info for that. 5 is trees. Zeroed, if zeroed. 6 is edits. And 7 is lighting. Okay, and I don't remember all those things I just said because there were too many of them. Height field, populate, or height field, populate, or trees. Height field, fill, or trees. Six is edit. And 7 is light. Now this is going to probably be too long to fit, and I'll have to skip some of them. 0, 1, 2, 3, 4, 5, 6, 7. Okay, good, that matches. And then once we get it working so it fits on screen, then we'll switch back to a release build and actually look at the numbers. Okay, so I bet edits are trivial. Looks like trees are trivial. Looks like everything's trivial. Looks like height field is where it all's going. Okay, and lighting might be. So let's leave out or and edits. Well, or, let me check what or is doing. Is or... So, edits, and what is or doing? It's only height field based. It's not checking every chunk. So yeah, we'll leave that on out too. Okay. So we'll do this in a tricky way. So if task of J or skip it. If 0 equals to task of J. This way, if I change the order of things, it doesn't break. Edits. Continue. Okay, and then let's run release and see where the time is going. And it's possible that if I just ran very sleepy, I would get similar data. But it's just nice that it's isolating it to task of J. What was the error? Missing parenthesis. Oh, yeah. It's just nice that this way I know I'm measuring each thread independently, the sleepy, without having to navigate the sleepy UI, and it's just directly embedded in the game. I can always see it. Okay, so height field, pretty big. Fill, noticeable. Trees, minimal. Fill and light are pretty similar. Okay, so let's switch to release. Oh, that was release. Okay. And it looks pretty stable. It looks like that's where the time is going pretty consistently. So the height field should be pretty fast to speed up. It's calling the Perlin noise, so it's slow, but it's also not doing a full 3D. It's not walking the Z, whereas the fill and the light are walking the Z. So, so I think speeding up the height field by looking at it and doing something to it should probably be pretty tractable. I had originally been planning on trying to profile everything, profiling the main thread as well, but I don't think there's any point given what the performance looks like. So I think that's actually good enough. So if I just wanted to do install the performance monitoring, I think I'm actually done. So at least let me check it in. But I think I will try to optimize that, but let me at least commit that. Performance monitoring for worker threads. And I'm only doing a few stir comps per frame. So like this is a dumb way to do this in one sense, but it's no big deal. Like I really need to put all of these onto an enum, and then I can test the enum values. All right, so let's look at what the height field is computing. We compute a Perlin noise here, and we compute a Perlin noise here. I assume that's where all the time is going. Compute height field, and that might be. That might be one or more Perlin noises too. Probably it's one or more Perlin. Yeah, okay, that's all the octaves of Perlin noise. Let's kill this code because who knows what it was for at this point. It's super ancient. Right, so how could we accelerate this? Is this in my here? I don't see where it's, oh. Is it in this? Yeah. Perlin noise. So one thing is I could try one of these other noise functions. If I'm only having integer inputs. It'll probably be lower quality. I don't only have integer inputs. No, wait. This is scaling times octave multiple. Oh, right. This is to decorrelate the octaves. And then I divide by it. So it is. Wait, so wait, what do these do? How are they? They're fixed point. Input is X, shift right S. Yeah. So this is designed exactly to do this kind of thing. But it's going to wrap around consistently. I can't do the octave multiplier on it. All right, so this will repeat, but let's just see what it does to start with. So that's equivalent to shifting by O. So yeah, it's SDB big noise. Is that what it's called? Oh, just big noise. Big noise, X comma Y, shift amount, and we get an arbitrary seed. I guess just, well, probably try to do a different random number. Now it'll still use the full second available. Oh right, and that scale value of that is different. I kind of also need to store it. Why don't we take the absolute? Oh, I see. I see what was going on here. Right. This output, what? 0 to 65535. So we want over 32768.0 f minus 1. I don't think this is going to be a good idea. I just want to try it and see what happens. Oh, it still uses scale. Dark. And I lost the declaration for that. Because it's here. So anyway, it should still take a millisecond for everything. I mean, a full second in every job, summed up in every thread. It just should redistribute where it goes if it's faster. Also, I haven't seen anything in chat for like 15 minutes, so... Okay, so yep, like the scale is totally different because the noise spread is different. Height field is now 0.37. And fill and light have come up. So yes, that made the height field generation a lot faster. It's just also way spikier. So let's divide by 3 and see what happens. All right, thank you for saying something in chat. And now it's too flat. But it's okay, noise-wise. Shape-wise, the shapes look reasonable still. It's just, it will wrap. So, what about fast noise? That's going to be even uglier, I believe. Oh, I want to change it from divide by 3 to divide by 2. Forgot about that. So all these things are their fixed point noise instead of floating point noise, so they can use shifts and stuff to compute. So now the height field, yeah, it's still just about the same speed. Doesn't look like fast noise was really faster than big noise. Big noise was just designed to have a little bit more randomness into the input. But it just tries to do less math than the Perlin noise does. Where's the Perlin? Perlin noise 3. Yeah, it's all hidden in macros. The Perlin grad, Perlin lerp. So fast noise is pretty simple. Big noise is only a little more complicated. And then the other thing is, of course, it's using shifts and fixed point math at the end to compute the final thing, but floats are actually faster, probably, than like a float mol is, an integer mol is not necessarily faster than a float mol. So I might want to actually make the final calculations be back into floats. So then the thing to do here is float compute height field octave float noise. What else does it take? In octave float weight. So now what I want to do is rewrite this so that this stuff is here. And then we say ht plus equals compute height field octave. Weight. Then we need the scale up here. Then we need all these up here, except NS. So this is just trying to refactor it. You'll see why in a second. So that should be the same. That was the intention. Put this back to 2. Put this back to big. right. So this looks maybe a little noisier than the old thing did. I'm not sure. So now what I'm going to do is I'm going to unroll this loop. Times. And I'll use Perlin noise, let's say for the first one, and maybe for the last one actually. And use big noise for all the others. So I still pay the full Perlin noise cost for the highest and lowest octaves. So the coarsest geometry will still, oh yeah, fuck. Scale is that. So let's see what this sort of hybrid looks like. So the largest shapes should still have Perlin quality, and the finest details should have Perlin quality. So I think that, like that pit, was probably something that was already there in the Perlin stuff. So maybe that's a reasonable compromise. And now when we look at the performance, well, the height field is still taking up 0.45. What did it used to take up? 0.6, 0.7, 0.8? I don't remember. Let's put it back to the old way. That return statement was missing, so that'll be broken. Yep. So the height field is at 60, and I only brought it down to about 50, so that really wasn't enough of a speed up. So I think I'm going to have to do something different to speed this up. Why taking 8 octaves? Well, the 0th octave gives you detail at the individual block level, and the 8th octave gives you detail that spans 256 blocks. Yeah, that pit is there. Well, that doesn't seem like 256 scale, does it? Who knows? Like, let's just isolate down to a single octave. O does not equal 7. Continue. Here's what the coarsest octave is doing. And note the height field, just calling 1 octave, the height field is still taking the biggest amount of the time. That's interesting. Oh, no, it's because I called the wrong one. Ah, okay. Now we'll see what 1 octave looks like. That didn't look like 1 octave. I have no idea why I thought that looked like 1 octave. There's 1 octave. So all the shapes are really big. although the transition between is weird. And this has this, there's still a function in here that's amplifying the desert in a weird way. So it's not exactly the Perlin noise, untouched. But you can see how all the curves are very smooth. All the ISO contours are these very smooth things. Okay. And then let's look at, actually I don't know if if the 0th level is actually contributing anything useful. That might just be garbage noise. It might be worth leaving that one out. It's causing that pattern. Let's look at one. The thing is that these, because we're looking at the height field quantized to voxels, we're missing some subtlety here. So yeah, again, it can't ever produce a bumpiness that's high enough for you to see. It just happens to be oscillating right around the thing. But when like there's an underlying slope, it's more obvious. So let's do this. Let's only show the 1st and the 7th. So there's something for the 1st to modulate, and then it'll be a little more obvious. Well, you can skip some middle octaves depending on the look you want. So you can see how this causes some breakups to the curve. Okay, yeah, and here you can see it sort of causes a dithery pattern along the edge. It's not very useful when you only have the 0th octave, or the 7th octave to have this 1st octave. But the whole thing is that the 6th octave breaks up the 7th, and the 5th breaks up the 6th, and the 4th breaks. So like, if we had only the 4th, I don't know exactly what this will look like. I mean, it also depends on how you're scaling it. If I scaled it up, it would be more obvious also, as well. I mean, I dealt with this when I was doing the generator. So here's what the 4th octave looks like, right? So it's little, you know, this stuff. But the curves are all still always this sort of scale. And so you add in the 3rd octave and it'll break up those curves. And meanwhile, then the 2nd octave breaks up the curves caused by the 3rd octave. Oops. Right, so it makes these less uniform looking. They have more squiggles to them. They're more oddly shaped instead of being sort of nice smooth curves everywhere. So, you know, yeah, maybe you could stop like if you did everything other than this. But the point is the big noise ones are so cheap that it's not really a big deal to do the big noise ones. And it will break up the curves. So yeah, that one's probably reasonable to stop there. But you'll never get a sharp edge because these things are too smooth. With other ones, it's possible that like this cliff, this thing might sometimes like have little bits of things jutting out in it. In fact, let's see if we can find this place again. It's right, we just go this way towards here and there's a pit. So let's look at what this slope here looks like. With all of the octaves. See if it makes a difference. So that's why I was trying to replace some of these octaves with cheaper octaves, but okay, so there's a pit somewhere over here. Where'd the pit go? It wasn't that pit. It was right here. Oh, over here. Okay. No, actually, it's still smooth. It's got a little bit of notchiness to it here. That little gap and stuff. Just makes it more irregular. You could definitely have biomes where you keep things smoother or whatever, but I'd like to still have biomes with the full thing, I think. So I think there just needs to be a different strategy for this. The whole thing is that what the Perlin noise is doing is computing values, these values at multiple octaves and smoothing them, but it's computing the same values at a lot of things and just smoothing them differently. So if we just shared that, if we compute the same corners that it's interpolating and share them across adjacent height points. We could definitely optimize this. The highest frequencies we can't optimize that way, and might make sense to use the big noise for the highest frequencies that we can't optimize, or just have some different way of generating them. One of the things that we're doing here is that if I didn't do these octave multipliers, then the noise generator wraps every 256. And the lowest frequency is space 256, so it means every 65536 times you stepped through the map, you'd actually hit the exact same terrain. And I actually used to have a hotkey in to teleport you that far, and we saw that on the stream that it was in fact happening. That if you teleported, the trees and stuff would be different because they're computed a different way. Yeah, it's right here. But that the terrain shape would be the same. So, so by decorrelating the octaves, it means that once you go 64K, you have to go a little more than 64K for this octave to line back up again. No, wait, it's actually this one's the highest one, the octave 7. You have to go this far times 6553K before it wraps. But the next octave won't have wrapped there. It'll have wrapped somewhere else, and they'll be out of sync now. And so it lets you go sort of the least common multiple of all of these before they'll be the same. Biomes is a term from Minecraft. If you want to know what I mean, check that out there. I mean, it's also a general term, BIOMES. But anyway, so that's a little sidetracked there because that's not really the point of this. I mean, it kind of is. If I could change that and that got enough performance, it might be worth changing. But okay, so I decided this wasn't really worth it. So compute height field. It's computed in a loop. And then we interpolate. Yeah, I don't know how to structure that to get that savings. It's definitely possible. I don't know how to do it. I mean, okay, here's a simple thing we do. We just define it on 16 by 16 intervals, and then we'll interpolate between the 16 by 16 intervals, and add some higher frequency noise on top of that. Now, the problem with that is that when we interpolate between these points, we lose the curvature, the slope at those things. Like the normal Perlin interpolation is a nice interpolation that that is smoother, that doesn't have line steps like that. But since we're voxel based, it might be unobjectionable. It might be we have to do something smarter, but we could try that. So float height field base. It doesn't go outside, it's going to go inside, but let me just think about it for a second. Gen chunk size x, and we'll just hard code this for now. Height field spacing 16. And we have to sample it to 4 on either side, so we'll need an extra 1 on the left and an extra 2 on the right. We need 1 all the way in the rightmost column, and then 1 past that to interpolate. And we need that in 2 dimensions. Gen chunk y size y over field spacing +1 +2. Okay, and then we will do for j equal negative height field spacing j less than gen chunk size y less than equal to gen chunk plus height field spacing j plus equal height no yes height field spacing. We want the same for I. Then we want to compute the correct x and y, and oh, we need this whole mess. But maybe we only need it here. Maybe we won't need it in the other one. Oh, and we have this hack for the Perlin noise that we're still paying. That's why it's so slow. It's because we're always paying this one. And we're always paying this one. So even when we got rid of all of them, we were still doing those. That's part of the problem. So I kind of want my big noise back. Well, let's just go ahead down this path. Let's change it to 8, though. Now that I noticed that. Alright, so first we put all this up here. There we go. We don't need the or, but we do need the weight. This one only needs the weight. We do need the ground top here. Height field int here. Height field int. Okay. Height lerp. We're gonna lerp that. Okay, so float weight field base. It's the same thing. J index, I index, J index 0, I index 0, this was I index, J index. Okay, so we compute a weight, clamp it, and then the weight field base. We don't have to clamp it. We could clamp it after. Maybe that's better. J index, I index equals weight. And now this uses x plus I and y plus j. That's correct. Don't have to do anything special there. Then we do that. Height field, and we say height field base j I equals height. Boom. Then when we come back through, we can get the weight by interpolating. Interpolate. Go ahead and use the I index. No, we can't use the I index and J index. So I index equals I over height field spacing. J index equals. Oh, and these round the wrong way. Dang it. I hate you. I hate you. I hate you. So we will use right shifts that are undefined on negative numbers because we want to right shift some negative numbers and have them stay negative, and there's no way to do that in C unless you rely on shifts doing that, which you can't rely on, but we're going to rely on it. Because stupid people decided to make that not work. Darn you, you stupid people. Okay, so the correct value for weight comes from interpolating. I'm just going to type this. I don't know what it's going to end up being. We interpolate from weight. Let's call this base and get rid of the extra word because I have to type it a bunch of times here. It's going to be interpolate weight base of. Oh, I need these. Weight base of ji of ii, weight base of ji of ii plus 1, weight base of ji plus 1 ii, weight base of ji plus 1 ii plus 1, and the interpolation factors are I and 7, j and 7. Field interpolate, weight. Float interpolate, p00, p0, wait, which one did we add to first? Yep, p10, float p01, float p11, float x, float y. Float p0 equals sp loop, y, p00, p01. P1. So there's a bilinear interpolation for you. If noise func is a bottleneck, maybe instead of generating distant chunks by calculating noise, you can mix and match properties of the first chunk. But then they wouldn't be as varied. I mean, there's arbitrary ways you could try to generate terrain. I just want to do the simplest thing to start with, and the simplest thing is to just use Berlin noise. So wait, so what happened to all the other stuff? Did I move that into wasn't there a bunch of other stuff in this calculation before it computed the height field? Or was it just the height field? Oh, it just computed the height field. All right. Not sure how I lost the assert height greater than 4, but so that was that. And then we clamp it. Then we're going to do the same thing with the height field. Field interpolate. Oh yeah, my X isn't right yet. I just noticed that. Height, 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 height. Okay, and then this interpolate, I'm actually passing in X equals IX over height field spacing. So that's that. That was that, etc. Okay. Maybe. I'll have to switch to debug. And I don't expect to speed up yet because I still have the OR hack in there. IYX float. Oh, yeah. Field interpolates. Yeah, it's really just interpolate. It's bilinear. So the results should be slightly different, or significantly different actually, because I lost the lowest octaves at this point. And I'm doing the linear interpolation. I don't know how that's going to shake out. Well, they are different heights than they used to be, clearly. This stuff isn't sitting on the ground anymore. Don't know why that stripe is there. Okay, so the stripes, there's something buggy about determining the terrain type. I don't know where that happened. That was in weight, right? Weight is what determines the terrain type. So there's some bug where I don't have the margins correct. Oh, I forgot to offset by 1. Because these go up to negatives, but my array is not negatively indexed. So I was just accessing random data. Alright, yeah, it's pretty similar terrain. Loses the higher octave roughness. I'm in debug, but the performance has shifted to lighting, but let's see. Okay, so I need to do this faster. So what was height or doing? Just computes a number. What do I use height or for then later? Just check some range. Okay, so height or, we're going to change to an int. Short even, and unsigned short, since that's what those return, and we're going to call big noise x plus I plus j go do that, and then we're going to check height or less than that. All right, let's see how that does. It is C. Big noise 3. Was it just big noise? X, Y, 0, and seed. Okay, looks reasonable. I'd still like to put the higher octaves back in using big noise and maybe fast noise. Where's compute height? Compute height field, whatever it was called. So we'll have this one compute the first 5 octaves, or is it 6? X over scale. We're going to query it every 8th, so we want to divide by 8. Does that mean that? Wait, is this backwards? Divide by 8 is that. But I intentionally wanted it to be more octaves. I thought I'm querying it every 8. Oh, so it's that. So let's just do that to start with. I'll replace it with big noise in a second. So this should be fairly close to what the original thing is, although it's using a different interpolator for some of it. Let's go and look at what this pit looks like now. Pretty similar. But maybe that overhang is a little different. And then let's replace this with big noise. X, comma O. X, comma Y, comma O. Oh, we use scale for that, right? Yeah, yeah. Okay, let's try that. I never called it. Big noise into float. So we have to divide that by 32768. 0, subtract 1, and then the whole thing needed to be divided by 2. Because that was what brought it more closer to the right scale. Okay. Now you call it compute height field delta. Here. Right, plus equals compute height field delta. X, Y, weight. Weight is basically the biome selector. And then we want to make sure those octaves are... Wait, this looks smoother than it used to. That may be the effect of the 8x8 thing. And we want to make sure this is having some effects, so let's scale it up just to see. And I didn't bound it. I made it blow up. Height field. I don't know what the highest point it used to be. Let's do that. Not sure why the high frequency spikes would spike that high, since they're supposed to have a pretty small scale. So I might have a bug. Yep, kind of looks like it. I amplified them by a factor of 6 and they went crazy. Am I on the wrong octaves? I don't think so. Compute height field delta. Compute height field delta, where is that? Compute height field delta times 3.0f. Divide it was fine. Oh, that's fed into the NS. Yeah, so I don't want to scale it up before feeding it into the NS, because then that gets, there's the cubic or quintic or quartic, I guess, there. So it needs to get scaled up here. 1.5, it's technically a double, and VC6 is a little... There's a mode in VC6 that's a little anal about that. Okay, yeah, I don't even see these. I don't see... Oh, here's a little bit of a change here. So maybe I don't need these. Maybe you're right. I think that's causing that steep drop off there, maybe? Yeah, that's clearly kind of buggy because it's has seams along these things. Am I not running these at the octaves I think I'm running on that? That's very weird. I don't really understand why that's having the seams where it is. It may just be that that noise is not accurate enough, or I'm misthinking these octaves. 0, 1, and 2. No, the 0 are the... That's very odd. The largest one should be 4 by 4. I don't know why it would have these effects on like the 32 by 32, unless that's just an artifact of the actual bad noise gen. What? There's something I'm missing that's causing these artifacts to be on large boundaries. I don't understand why. Why they're happening at that boundary. What would this... Why would this... Oh, it's the shift amount. Goes up to 2. Okay, so this one seems to be having no effect. The 0th octave. Which I don't really understand. Well, there's that artifact again. So that must be an artifact in the random number generator. But why is the actual multiplied height value not showing up? Why is it not 0 to 1? Big noise returns 0 to 65535. Divide by that, so it's 0 to 2. Subtract 1, it's negative 1 to 0. Divide by 2, it's negative 0.5 to 0.5. Then we run into this function. Checks the sign, does that, just uses ns unchanged over 4. Let's see if we leave out the Cordic expander. Since it's doing that independently to each octave. Nope, look, it's clearly artifacty. This is very odd because I used these in a different height field generator. That's where I copied these functions out of. Am I passing in the right X and Y? I'm not. That's the problem. I bet you a mile that I'm passing in the exact same X and Y to these because I forgot to add I and J. So let's put this back. Let's scale it up like I wanted to originally. Field delta. Yep. That's why. Jeez. Double the float, fuck you. All right, my God. So none of that testing was correct. None of that testing of, is this contributing anything? So now I have it amplified, and yeah, you see these little 1 pixel spikes, but you also see how broken up these edges are. And if we go over here to the slope, I assume the slope will be more broken up than usual. Oh, not really. And this curve shape is pretty stable. But that's with adding the huge scaled up one. I guess let's add up an even more huge scaled up one. The thing is, these octaves have really low impact because they're in the inside compute height field octave. We're really scaling them down. But in real life, you might make biomes that scaled them more strongly. So yeah, here it's overly scaled and it's just noisy ground now. So they're definitely contributing. They're just contributing subtly. And like I said, for different biome types, you might want to weight these differently. So I don't want to get rid of them entirely. But I can switch them to a faster noise like I did here. All right, so I think that's good enough for now. We'll look at the profile again. Well, I'm using C. It's true that, yeah, the library. What did I... Has that pit always been there and I just... Did I just do something that broke that? Like, that's way bigger than it used to be, I thought. What did I just change? I didn't change anything. I mean, I got rid of the scale up on that. I don't remember that pit being that big. Very weird. Maybe it was. Maybe it always was, and I just didn't think about it. I remember commenting on that pit earlier when we were looking at the individual octaves, but I don't remember it being that big. All right. So now we look at the performance. And as I said, it's unfortunate that I don't have the ability to like say, okay, it used to take this long to build this, and now it takes this long to build it, because it's just measuring the amount of time per thing. I could measure like the number of times per job or something, but presuming the job count has come up a lot from what it used to be. So so now the height field is that long. The fill is now slower than the height field. Yay. And the lighting is even slower than the fill. Okay, so the lighting is the next thing to do. Let's check this in. Of course, I don't necessarily want to use height field generation in the end. I'd actually like to generate 3D terrain by doing columns, full Perlin noise columns, but that's even slower. So I have to figure out how to do all that. Optimize height field computation. So I don't know how much faster things got because of that, but all right, so let's look at the lighting. Lighting is just, the problem is that we're visiting a lot of data, I believe, because it's just filling the full thing. Now, there is something in this data structure to allow you to know if a thing is entirely empty, and I don't know that we make use of that. So gen chunk, where is the gen chunk defined? Gen chunk, ref count partial, non-empty. There's this non-empty flag. So we like to set the non-empty flag if we're not already setting it. To do, compute non-empty based on below updates. Rock on. So we can initialize non-empty based on the height fields. So we need the ground top, which we have right here. Ground top. If so, I assume these correspond directly. If ground top is greater than or equal to the top of this segment, which is going to be z-seg times z-seg, oh, that's z0, z1, whatever z1 would be. So z1 equals z0 plus z segment size minus 1. So ground top is greater than or equal to z1. That determines the non-emptiness. GC arrow non-empty of z-seg equals ground top greater than or equal to z1. If the ground is higher than the top, it's not empty. Okay. Then if we ever store anything higher than ground top, we need to count for it here. And ground top being the height field. Height or, I think, forces it up one. No, it just makes the top ones be. Height plus 1 minus z0. Height is what? Height is the height field. Ground top is the height field. Height plus 1 minus z0. And then we'll store to it. Z0 is the offset, so we do store to height plus 1. So currently we're making this grow by 1. So if z limit equals 0, oh wait, yeah, then this one is definitely not empty. Oops. And then when we do a tree, go into the tree height. Tree height, what's the highest block we actually set? Z, leaf top. If leaf top. So we just do, so this might not actually intersect this thing. There's going to be a tree just off the edge and its tip is outside of it, but that's okay. We'll set this non-empty. Z segment log 2, something like that. Z segment size log 2. We just force that to true. What have I been saying it to elsewhere? 1, forgot to use true. Okay. That accounts for trees. Is there anything else we build? Edit chunks. GC arrow non-empty ZS. That's true. Is 3D magic? I don't know. I mean, I came into 3D through software rendering where you had to do everything by hand and understand it, and it's mostly linear algebra. And I didn't actually have a linear algebra education. I did it in high school from a magazine article that gave enough info about everything. Okay, so nothing crashed. I don't know that I'm actually computing it correctly, but that's okay. So now when we get to the lighting, we can say, do we need the lighting on, we do need the lighting, we do need to compute the lighting one outside of the blocks, one higher than the box. So the non-empty, we won't actually want to store highest Z. Now we gotta find all the non-empties and fix them again. Oh, it was already trying to set it here. Clever. So what do? We just loop over all of them. Let's just do this directly. For Z a variable ZSeg equals 0 ZSeg less than. It's the same loop I have down here, but let's just do it up front. Z segments. Oh wait, ground top. I don't have a ground top yet. What is ground top? It's garbage. All right, let's just not even touch that. Let's just do it here. Highest ZSeg equals clamp ground top minus Z0 0 15. No, Z segment size minus 1. So we want to store how high the highest point is within this chunk. So it's relative to this chunk. Kind of implies we could just store it globally and probably use that instead of storing this. I wonder if that would actually be simpler. Yeah, it probably is. It'll be the highest one that's set. That'll be easy to be consistent. And then highest z equals this to be max. So let's clamp bottom. I think this is all constrained, like height is really constrained to much smaller, so it can never do it, but just to be on the safe side. Because this is, well, I guess it doesn't need to be an unsigned char, since there's only one of them at this point. I don't get any benefit from doing that. Bottom. So might as well just be that. Dun, 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 dun. And then GC highest v equals this one. I have to actually do the work to decode it. It is blocks. Oh, height is right there. Height. Okay, so we're looping through by segments so that it's coherent, and then we say if the entire segment, so if z_seg times the segment size is greater than gc arrow highest z, the entire thing is higher than the highest block plus 1. We don't care about any of the lighting in it else. So that'll shortcut a simple case. We'd also like to do underground, solid underground maybe, and optimize that stuff out. Let's just see if this works. That's that one went to the other one. And here we just have to memset, but even this just still has to touch all of that data, so it might still be slow. I guess I don't have to touch it. I don't use it, so I could leave it alone. Does this get used by the neighbors? It does get used by the neighbors. So if the neighbor had a higher height, it would actually need to know it at the edges. Oh, but this doesn't do any height stuff. It's just looking at the values of the stuff. Why does it have to convert rot? What is that doing? Oh, it's storing the rotate. Right. It stores the rotation value in that. So it does need to be filled out on the edges. And let's just do it to start with. See how the performance goes. look for lighting bugs. Not lightning bugs, but lighting bugs. Oh, there's a... No, that's not a lighting bug. That's like a little gap. Don't see anything wrong. Probably didn't help performance very much, though. Because we still have the hole under the ground. So height field, fill, light. Light is now smaller than fill, so we did speed it up a bunch. But I bet we can speed it up more by doing the underside as well. Highest Z to lowest Z. Now, if the terrain doesn't stay solid, if you start doing tunnels under it, like Minecraft, then this is not going to be a speed up. So it might be wasted effort, but ground, solid bottom. So solid bottom is solid bottom equals STB max top height. This is actually going into the neighbors too, interestingly. So maybe that prevents the neighbor problem as well with the lighting. That should be min. So anything below this is definitely solid. And we don't currently make any holes, so I don't have to update that anywhere. And then here we can say for z seg times z segment size is less than solid bottom. Then we also do not need to fill it out correctly. Yep, now light's down even smaller. And now let's see if I can do this thing, which is I want to set it to 255 around the edges, but I don't need to set it in the middle. I need to set it on the edges in case the neighbor needs it, but I can just leave it undefined in the middle. We'll see if that's true. So memset GCP lighting of J. How do I want to do this? No, I need all of the columns. So I need that. Is that right? No, it should be columns. Yeah. So lighting of 0. Segment size. Both sides, and then do the same thing on this one. And we're replacing that with it. So we'll just leave the memory uninitialized because it should never get rid. That's the theory. This becomes light as well. But I don't know if that's right. Nope, I always got something wrong there. Giant undefined regions show as giant undefined regions. So I'd probably broken the lighting when I set them all to 255. I was probably not getting shadows in there and just didn't notice. Don't know why it only happened on some sides and not on others. It's odd. I guess that's how big a gen chunk is. There's something about it. So if I zero this, let's check if the shadows are missing from those. Yeah. You can see all the shadows are missing here. It's a little confusing once the lighting direction takes effect, but from this angle it's really obvious. Okay, so why is that logic wrong? Is it only that part of the logic that's wrong? Yeah. Okay, so it's the solid bottom logic that's wrong. Solid bottom. So solid bottom is the lowest ground top anywhere in the area. Lowest. Anything lower than that has to be solid. So if the entire chunk, if we go to the top of the chunk, plus 1 times z segment size, and that's below the solid bottom, then it should never be accessed. And so it shouldn't matter what we set it to. But we could definitely set it to solid instead of to hollow. Which might affect the adjacent guys, but it shouldn't affect the whole thing like we were saying. Nope, it still does. That was why there were the edge columns. Okay, why does that test not work? What's wrong with that test? We're processing this segment. So we look at the start of the next segment. If the start of the next segment is below the region where everything is solid, then we can set the lighting to solid 0. And edit actually makes things non-solid, so I do need to, but it's clearly not the edit case that's triggering this, but I do need to do something with that. Wait, why am I using solid bottom, not GC arrow lowest Z? Did I ever set that? Never said it. Although it should still be the same anyway. So why would this not be right? I don't know. I don't understand. What's going on? Help me. What? By the min and the max. Oh, there you go. Alright, looks good. Has shadows. And then let's look at the performance. Light Still significant. Still could be optimized. But fill is now dominant. And light is way cheaper than height field now, even though that's the sped up height field, which means we've probably made this a lot faster. So let's check that in. Let's look at fill real quick. And then let's see how long it takes to fill in the far terrain now. It's still going to be too slow, but it'll be faster. All right. So the fill. The fill is this part. Still calling big noise. What happens if we make it not called big noise? I think that's not a big deal. It's probably all the bilurps. It's probably just everything, actually. Oh, there's no ore anymore. And something is relying on there being non-zero amounts of ore, it looks like. Why did I exit? That was dumb. So one thing is that the places where I intentionally built on ore are no longer built on ore, because there's not, the ore isn't being generated in the same place anymore. So that one doesn't operate, because it's not built on ore. The destroyer can still operate. It doesn't rely on ore. Oh, did I hit the same thing? Nope. Huge hack to keep track of ore for now. Probably generating too much ore. I probably, this thing is probably huge now. Oh, this is not getting profiled. This is a huge hack, so. Next, Ojai. I'm not allowed to look at next Ojai? Why can't I look at next Ojai? Oh, I'm in release. So that's probably generating too much more. Look, we only handle 500,000. I think it's SB. The Udict overflowed anyway. Anyway, what was the performance like? Or did it crash before I could see the performance? Oh yeah, I could have been tracking how many jobs we're running, because we're now up to 250 jobs. Yeah, the fill is still dominant. So, bilinear interpolate, wait, bilinear interpolate, you talk fill delta, skip that. Not much more I can skip in this, though. Oh, wait, no, this is height field step. No. My bad. Sorry. This is height field step. This isn't affecting anything. Fill step is next. This is fill step. And the main thing is that it's stepping over every single thing. Again, it could use the lowest, highest clipping. It's never visible if these are true. so we can do something simpler, but it might still be too slow because we're just mem setting a ton of memory here. This is backwards. It's greater than highest Z. Lowest Z. Set speed arrow block I BT empty Z segment size. So I don't know if this is really any faster because it's just touching all the same memory. Because this is still only looping over this many things. It's computing a bunch of stuff, but it's probably dominated by the mem sets. I at least get to skip mem copying the rotate field. I don't have to initialize the rotate field in this one. I'll just set an arbitrary, it doesn't matter what object I set because you can never see it, at least in theory. Field is now cheaper than height field. So I think we sped it up a bit. Did I break anything? Do I see any stone where it shouldn't be? Looks okay. You know, this is not going to help the worst cases. Like, once you actually like build crazy shapes, you're just going to fill stuff up. Oh, the flying physics is blowing up because my frame rate is dying or something. Oh, it's the ore again. Why is this? Didn't I switch it back? I thought I switched it back. Big noise. It switched back. Or where's that? It's in logistics. Or count. If or count plus plus. What is or pending? Can I ever actually? Oh, okay, yeah. I see. This puts it in, but this puts it in the dict. Why is there an array? This is fetching from an array, indexed by or processed catching up to or pending. So or pending should be putting in an array. It is. So what is this dict for? What? Why? Alright, it is actually used. So I can't not update it. I just don't understand why. I don't know what's going on there, but I'll just work around it for now. It seems like it's creating a separate record for every ore. Okay, now some of my workers aren't doing any work. Which doesn't make any sense at all. And the tops of these trees, the lighting is busted. Yeah, some of our workers have gotten stuck because I did this. Oh, because I never unlocked the mutex. So, is the lighting still busted? Yes, it is. Okay, so I broke the lighting. The trees are not updating the top correctly. Looks like. High C. Oh, they probably update ground top instead of updating high C. No, high C, leaf bottom. The max. No, not leaf bottom, leaf top. Idiot. Nobody called me on that. Alright, here we go. It can take a long time to come back up to speed. I can't really put a number on it. Have to figure out what things we're doing, why things interact. You can see some of that on the stream where I'm like, I don't understand why this works this way, and I'm very confused for a long time. Why is that flying? Well, my frame time is spiking. Why is my frame time spiking so high? Oh, because I'm drawing out to the distance and my GPU is not keeping up these days for some reason, I think. Or something. Something's going wrong there.